Mango Math presents Math Magic, a pre-algebra game. Math Magic is a pre-algebra game that follows under the strand of students using variables to represent quantities in a real world or mathematical problem and construct simple equations and inequalities to solve problems by reasoning the quantities. Math Magic has some math terms to help increase understanding, and those terms are inductive reasoning, making observations, noticing patterns, drawing conclusions, and determining what may be true. And then deductive reasoning, using logic to draw conclusions from statements that we accept must be true. So we'll be using these terms within solving the equations. The supplies that are in the pack, along with the information sheet and directions, will be cards that have the Math Magic on them, a Math Magic board that's laminated that you can use a dry eraser marker on. There'll be square tiles and circle counters that you can also use. To start with, one student will select a card, and that student will not allow the other students to see the card. The other students will get a Math Magic board and the dry erase marker. So as the student reads the directions slowly, the other students will write out the math problem on their board. So to start with, the students will choose a number, and they can choose any number. And usually I tell them that they're going to be multiplying, adding, and dividing that number. So think about what number you want to use. So often they'll stay with a smaller number. So let's say they choose 7. I'm going to read the next direction, which is multiply by 3. And then add it by 6, and now we have 27. Divide it by 3, I now have 9, and then subtract that first number, or the number that you chose. And then once they subtract, I'm going to say, okay, who all has the answer of 2? And hopefully everybody raises their hand, because that is the only answer they can get once they go through this process. So once they do it and say, okay, let's choose another number. Let's make sure that they're all different, so you can have all the kids that are there, each choose a different number. But we'll start again, and let's say we choose 14. All right, we're going to go through the same process. Multiply it by 3, we got 42. Add 6, got 48. Divide by 3, I now have 16. I subtract that first original number, and now I have 2. So everybody has the same result, 2. So how do we do this? So we can take out the board and use counters to show the same math happening. So let's say I take counters. I'm going to do the same problem. I'm going to choose my number, and I'm going to represent that by a tile. All right, I'm going to multiply that tile by 3. I now have 3 tiles. I'm going to add 6. Now that's different than what we're originally doing. So now I'm going to use a different object to represent that. So I'm going to use a circle counter, and I'm going to put 6 counters up there. So now I can divide by 3, and I'm going to divide everything by 3. I'm going to take out 2 of the tiles and then 4 of the counters, so that I'm left with 1 tile and 2 circle counters. I'm going to subtract my original first number, and what I'm left with is 2. So they can see how objects can also represent the unknowns, and then using the same algebraic process with them. So let's now look and see, how do we do this with variables? So let's go back to our board. We're going to use variables instead. We're going to have n, and we're going to multiply by 3, so we can say 3 times n, or 3n. We're going to add 6, so we have 3n plus 6. We're going to divide by 3, so 3n plus 6 divided by 3 equals n plus 2. So notice that we've multiplied by added the 3 on and multiplied by 3, and then divided by the 3. So we're doing everything in numbers that relate to 3. And so then we're left with that number 2, n plus 2, and I take out my original number. That gives me n. So if the students had chose a different number or a different card, this one has a little bit different to it. So let's choose a number. So I'm going to represent that by that counter, and I'm going to subtract 1. Well, I can't subtract 1 from a tile, so I'm just going to leave that to the side and think about I'm going to do that later. I'm going to multiply by 3. I'm going to add 12. I'm going to divide by 3. So then that's going to divide both sides by 3. So I'm left with 1 tile and 4 counters. I'm going to add my 5. Now at this point, I can subtract my original number, or I can subtract my original number, but I could also have that subtract 1. So I'm going to take that out as well, and I'm left with 8. So you can see the process that we went through on this one using the counters. So if I do a different card and I go through that same process, notice that I'm going to end up with the same results. I'm going to end up with that 8. Doesn't matter what number I choose. I could choose a 6 or a 13. I'm always going to end up with 8. So let's look at the algebra behind it. I'm going to choose a number, n. I'm going to subtract 1, n minus 1. I'm going to multiply by 3. So I have 3 times n minus 1, which is the same as 3n negative 3. I'm then going to add 12. So 3n negative 3 positive 12 is the same as 3n plus or positive 9. I'm then going to divide by 3. So 3n plus 9 or positive 9 divided by 3 is the same, equals n plus 3 or positive 3. I'm going to add that 5. So n positive 3 positive 5 equals n positive 8. And now if I subtract the n, I'm left with just the 8. So it has the same results, and you can go through the algebraic formula on that. And they can see where they have multiplied in the same amount as that they divided out, except for that last amount of 8. Some guided questions to promote critical thinking. If the original number is a number trick, if the original number in a number trick is represented by an x, what will represent the doubling of that number? The adding to the original number, the number 1 larger than the original number, dividing the number, and adding the original number to itself. So those are some questions which gets into how to write expressions, and how would we write those using these different ideas. How do we show double of a number? That would be 2 times the x. Adding the number would be 2 plus, or x plus, let's say it's 2, we're adding on 2. The number 1 larger would be n plus 1. Dividing the number would be n divided by whatever number that is. And adding the original number times itself could be 2 times the original number, or that original number plus, so n plus n, or 2 times n. So those are some ideas. The students can try to create their own math magic cards. That's a good critical thinking process to go through. They can use deductive reasoning to come up with, how do we know this is going to come up with this result every single time? It's a great activity, so enjoy.